slope of a secant graph of a function at 0 and 6, what would you do? This is a secant line, not a tangent line. Makes a little difference. Well, a secant line hits the graph at 2 points. So you're finding the slope of a graph like this that hits it here and here. What's the point here going to be? Oh, come on, AP calculators. 0, 1. Thank you. You plug 0 into the function and figure out what it is. What's this point over here? 6, 5. How do you find the slope with 2 points? 5 minus 1 over 6 minus 0, 4, 6, which is 2/3. Bang. Slope is a secant line. Okay? Okay. Any points where that's not differentiable? 0. It's not differentiable because there's an asymptote there. It's discontinuous. And where it's discontinuous, it's not differentiable. All right. Average rate of change. Average rate of change is what? Basically slope. So you stick in these numbers. H of 4 is what? 2 to the 5th. That's 4 plus 1, which is 32. H of 2 is what? 2 to the 3rd, which is 8. So you get 32 minus 8 over 4 minus 2. Y2 minus Y1 over X2 minus X1. 32 minus 8 is 24. 24 over 2 is 12. Average rate of change. If g of x equals cotangent of x, what's g prime at pi over 4? Well, you'd have to grab your note card and look at the first derivative of the cotangent to figure out that the first derivative of cotangent is cotangent x cosecant x, correct? Nor is it cosecant squared. It's cosecant squared. So it's negative cosecant squared. Okay? So it's negative the cosecant of pi over 4 squared. The cosecant at pi over 4 is 2 over the square root of 2, or just square root of 2, right? So the negative of the square root of 2 squared is negative 2. What's the first derivative of x over sine of x? What rule would you use? Quotient rule. Sine of x times first derivative of the numerator minus the numerator times the first derivative of the denominator over the denominator squared. So it's the sine of x plus x cosine of x over sine squared of x. And that's where you stop. Okay? You don't try to factor and cancel or anything like that there. Okay? We good with that one?
Yeah.
X to the 5 halves, what rule is this? Starts with a P. Power rule. 5 halves x to the 3 halves power. What's the best estimate for the first derivative at 4 using this table? What would we do? Find the slope between 3 and 5. So you take 112 minus 95 over 5 minus 3. 19 over 2, which is 9.5. We good? First derivative of this bad boy. What should we do before we try to take the first derivative? Yep. Bring the exponents in the denominator up to the numerator. And then do the power rule. So negative 4x to the negative 5 plus 6x to the, oop, we're going the wrong way. Wait. Now you go down by 1. Yeah, negative 5, negative 3, plus. If you put it in like this on your computer, it'll be just fine. I think if you also put negative 4 over x to the fifth plus 6 over x to the third plus 3x squared, that's a way I forced my old students to do it, but I have figured out that, don't have to do that anymore. Is this function both continuous and differentiable at negative 4? How do you check? Plug negative 4 into both. So if you plug negative 4 into here, negative 4 squared is 16, half of 16 is 8. Plug negative 4 into here, you get 16 plus negative 20, which is negative 4. Is it continuous? No. So then would it be differentiable? No, because if it's not continuous, it cannot be differentiable. Okay? If it is continuous, does it have to be differentiable? No. And on this one, it wouldn't be, because the slope of this one would be different than the slope of this one as they come in. All right. What rule would you use here? What's the name of that rule? Product rule, because you're multiplying. So it's x times the first derivative of the cosine of x, which is negative sine of x, plus cosine of x times the first derivative of x, which is 1. So it's negative x sine of x plus cosine of x, or cosine of x minus x sine of x. Katie tried to find the derivative of that using basic differentiation rules. Here's her work. Where did she go wrong? Or did she even go wrong? If she didn't, then that's wonderful. But what do we got here? What'd she do wrong in the third step? No, third step is fine because it's.
Oh, I didn't see that out front. Yeah, my bad.
10's in front. So I think it's just fine. No mistake. All right. What's f over g in this case? This is what we just got done with the last section. All right. So what do we have to do? We have to take, let's just write it out in terms of f and g. And what rule would we use? Quotient. So g of x times the first derivative of f of x minus f of x times the first derivative of g of x all over g of x squared. So we know g of x is 3, the first derivative of x is 5, minus f of x 2 times the first derivative of g of x, negative 6, over g of x squared, 3 squared. So you get 15 plus 12 over 9. 15 plus 12 is 27 over 9 is just plain simple 3. How do we take the derivative of this bad boy? What's the first derivative of 3e to the x? Yeah, what is the first derivative of 3e to the x? I'm kidding around. I am such a humorous guy. All right, what's first derivative of 5x squared? 10x. Okay, first derivative of x to the fourth. 4x to the third. You guys are derivative masters. Tangent equation. Okay. What are we given?
You're given the slope
We're given the slope and the
x.
point. The point is 8, 1. The slope equals 2. Put it in point slope form. Y minus y1 equals the slope times x minus x1. How do we find the derivative of that? So it's x to the negative 11th. So it's negative 11 x to the negative 12, or negative 11 over x to the 12. Okay, this is a problem. So g of 1 equals negative 2. The slope at g of 1 equals 7. H of x equals the square root of x. F is a function where f equals g times h, and we want to find the first derivative of f at 1. So here we go. To find the first derivative of f at 1, we have to do the product rule. So it would be g of x times h prime of x plus h of x times g prime of x. Well, we know g of x, g at 1 is negative 2. H prime of x, we don't know what that is, but can we figure it out? So if this is x to the 1/2, what's the first derivative of that? 1/2 x to the negative 1/2. If we stick in a 1, what's 1 to the negative 1/2 power? Well, the square root of 1 is 1. Put it on the bottom, it's still 1. So the first derivative of h of x is 1/2, correct? Then h of x, if we stick h of 1 in there, that's still 1. First derivative of g is 7. Just do the math. Negative 1 plus 7 is negative 6. Okay? I think this might have a little bit more. First derivative at negative 2, how do we figure it out? Quotient rule. Quotient rule. X squared minus 3 times 2 minus 2x plus 5 times 2x all over x squared minus 3 squared. So if we stick the negative 2 in right away, negative 2 squared is 4. 4 minus 3 is 1. Stick the negative 2 in here, we get negative 4 plus 5 times negative 4 all over negative 2 squared is 4 minus 3, which is 1 squared. So 4 minus 3 is 1 times 2 is 2. Negative 4 plus 5 is 1 times negative 4 is negative 4, so minus the negative 4 over 1, which is 6 over 1, which is 6. Okay, here's g function. What's the bigger, g prime of 1 or g prime of 3? What is that asking us? Which one is a bigger slope? This slope is like this slope is like this, so obviously g of 3 is bigger, so it's A. G prime of 1 is less than g prime of 3. Which derivative is described by this? Okay, the sine of x minus the sine of pi, because the sine of pi is 0 over x minus pi. So it's just the first derivative of the sine of x where the function is going towards pi. First derivative of this one. 2x minus 7. First derivative of this one.
2 minus 3 cosine.
Yep. The tangent line to the graph. So what do I have to do with this function? Find the first derivative, which is 6x squared
Plus 10x.
plus 10x. What do I have to do with the x equals 2?
Put it in.
Plug it in for the g prime. So negative 2 squared is 4 times 3 is, or 4 times 6 is 24. Put in a negative 2 there, that's 20. So it just gives us 4, right? Then the negative 2 also has to go in the regular g function. So 2 times negative 2 cubed, which is negative 8, plus 5 times negative 2 squared, which is 4. So this is negative 16 plus 20, which is also 4. So you have your point is negative 2, 4. Your slope is 4. Put in point slope form, y minus y1 equals your slope times x minus x1. So y minus 4 equals 4x plus 8. Add 4, y equals 4x plus 12. And that is it. So I will put the test out. You will have all the way until next Tuesday to get that done. And then on Tuesday, we take the test.